Hi fellas, in the coming videos we're going to be using three different methods to solve simultaneous equations. The substitution method, which is what we're looking at first and here, the elimination method, and then we're going to look at matrix methods of solving simultaneous equations. So firstly, the substitution method. Now the substitution method is great when you've got a prime numeral, either x or y, as the subject of an equation. Here we've got y the subject of both equations, so it's screaming out substitution method. This is the big idea I want you to get. And the big idea is this, that if we're saying y is equal to 4x minus 2, it means we can replace that y with 4x minus 2. And then we've got a reasonably easy equation to solve in terms of x. Of course, I could say that because y is 2x plus 8, I could replace that y with 2x plus 8. It actually doesn't matter which one I do. So, but that's the big idea I want you to get. Now, once we've got that big idea memorised, we can go ahead and solve it. What I want you to do is indicate to the reader what's going on as you do it. So we would say here, sub equation 1 into equation 2. Like so, and that means I'm replacing the y here with 4x minus 2. Okay, subbing 1 into 2. Okay, so let's do that, and what we'll get is so 4x minus 2 equals 2x plus 8. And solving for x, I get this. Subtracting 2x from both sides, I get 2x. Adding 2 to both sides, I get 10, and therefore dividing both sides by 2, x will equal 5. Well, that's very good. I've found x equals 5. Now what I need to do is find a value for y. Okay, so let's just move this a bit, get some more room, and let's see what happens. So again, what I want to do is tell the reader what it is I'm doing, and what I'm doing is subbing sub x equals 5 into the equation of my choice. Now it really doesn't matter if I substitute x equals 5 into that equation or that equation. I'll get the same answer. But generally, as a guideline, you pick lower numbers or equations with lower numbers in them. Try to avoid fractions if you can, things like that. In this case it really doesn't matter. So I don't know, I think I'll sub it into equation 1. And so y is simply equal to 4 lots of 5 minus 2, and therefore y equals 20 minus 2, which equals 18. Now fellas, when my variables are x and y, it's not a bad idea to write your answer as a pair of coordinates. Okay? So the answer, now don't get the order wrong, x goes first, followed by y, the order is vital. And why we do that will be seen in the next slide. So here are my two equations, y equals 4x minus 2 and y equals 2x plus 8. Really what I've found, if I apply my equations to a graphical context, is the point of intersection. So you can see there my answer for x and my answer for y. So that's why when the variables are in terms of x and y, it's not a bad idea to write your answer as I did, as a pair of coordinates, like so. Okay? Here's a pair of simultaneous equations, gentlemen, where the substitution method will probably be the preferred method. Now you'll notice that we don't have x or y as a subject of the equation, of either equations, but we can make it so by a little bit of simple manipulation. So if you look at equation 2, you'll notice what you can do is make y the subject of that equation by simply adding 2x to both sides. So what we get therefore is y equaling 8 plus 2x. Now I'm going to label that as equation 3 because I've meddled a bit with equation 2 and it will help me explain to the reader what's going on as I do it. So the first thing I'm going to do is replace the y here with what y is, which is 8 plus 2x. Okay, so I'm telling the reader that what I'm doing is subbing, or substituting, equation 3 into equation 1. Most important you tell the reader what's happening. So therefore we get x plus 3 lots of 8 plus 2x equaling 3. Okay, therefore let's get rid of the brackets. 24 plus 6x equals 3. Collecting like terms we get 7x, and subtracting 24 from both sides we get negative 21. Therefore x equals negative 3. So all I need to do now is find a value for y and write my answer neatly, and I am done. So let's move that away a bit. Now what we're going to do is sub x equals negative 3 into any equation, really. I'm going to pick equation 3 because y is the subject of it, so it should pop out quite nicely. So sub x equals negative 3 into equation 3. It doesn't have to be equation 3, but it looks the easiest one to me to work with. So therefore y equals 8 plus 2 lots of negative 3. Therefore y equals 8 minus 6, and therefore y equals 2. So my answer, to write it as a pair of coordinates, is, what was x? Negative 3, and y is 2. And once again, fellas, if we plotted equations 1 and 2 on a graph, on a number line, I'm not going to do it now, we would find that the point of intersection is negative 3, 2. And that's the end of the substitution method.